Assalamualaikum and greeting to all. My name is Ahmad Syakimah bin Muhammad. I'm from Group 4, Section 2. My metric number is AE21003. Today, our group question is question 4. So now I want to discuss about question A. The question is obtain VFT and IT for T greater than 0 in the circuit. So our question, this is our circuit that have given for this question. So for question A, firstly we need to consider the circuit of figure 4 with IST equal to 3 UTV. So firstly we need to switch to frequency domain. For capacitor, the frequency domain is 5 over j omega ohm. For inductor, the value is 5j omega ohm. So next we need to find the current IT using the current divider rule. So we use I equal to IT and IS equal to 3 over j omega. After use the divider rule, we got the I omega equal to 7 over j omega square plus 8 over 5 j omega plus 1. So after that, we need to find the IS by transform the I omega to IS. So IS value is 7 over S plus 4 over 5 square minus 3 over 5 square. So next, we need to transform IS to IT. We must use the inverse Laplace. So by using the inverse Laplace, we got IT equal to 35 over 3 E power of negative 4 over 5 sin 3 over 5t ampere. So by having IT, we can find the VFT. So the VFT equation is VFT equal to RC dot IT. So we got the R value is 5 over S and IT value this one. So IT value this one. So we put it in the equation 7 over S square plus 8 over 5S plus 1. So we got the VFS equal to 35 over S kurungan S square plus S square plus 8 over 5S plus 1. Next, we need to use the partial fraction to explain the polynomial. So we got the last equation is 35 equal to A S2 plus 8 over 5S plus 1 plus BS plus C multiplied by S. So when S, so we need to use the tuple right and arrow method. So when S equal to 0, we got A value is 35. We need to make the value as a first equation. Next, we need use when S equal to 1 and insert equation 1. So we got the value 35 equal to 35 multiplied by 18 over 5 plus B plus minus negative 1 equal to B plus C. This is the second equation. Next, we need to use when S equal to 5 and insert 1. So the last we got the value is 35 equal to 1190 plus 25B plus 5C minus 231 equal to 5B plus C. So A, we got the value is 35, B is negative 35, and C is negative 56. From this value, we can find the VFT. So the value for VFT is 35 minus 35 E power of negative 4 over 5T cos 3 over 5T minus 280 over 3 ln negative power of negative 4 over 5T sin 3 over 5T volt. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Azim binti Ibrahim. My matric number is AE2010042. I am from Group 4, Section 2. So now I will explain on question 4B. The question asks to determine VFT and IT for t greater than 0 if IST is equals to 30 UT. By referring this circuit, so first thing first, we use current divider rule, which is the current in any of the parallel branches of a parallel circuit is equal to the ratio of opposite branch resistance to the sum of all resistance multiplied by the total current. So we use this rule to get our I omega. So this is our I omega, which is 34 over J omega squared plus 8 over 5 J omega plus 1. So next we need to change our I omega into S domain. So this is our I in form of S domain. So after that, we transform to inverse Laplace in order to get our IT. Since inverse Laplace is used to transform the function variable from frequency domain to time domain. This is in time domain form. Since we already obtained IT, so now we can find VFT by simply using Ohm's law, which is VFT equals to IT times by RC. And then we will get our VF in S domain. So for the last step, we're using partial fraction to expand polynomial. This is the fraction, and then we need to find the value of A, B, and C. So in order to get those values, we substitute S equals to 0, S equals to 1, and S equals to 5. Therefore, we get value for A is equals to 170, B equals to negative 170, and then C equals to negative 272. So we substitute the value that we get into our fraction. Therefore, we will get our VF in S domain form. So in order to get our final answer, we transform VF in S domain to time domain, and we will get this answer. So this is our final answer.
Hi, my name is Ahmad Salim bin Azlan, matric number AE2010030. So for question C is the comparison between result in A and B from question A. We got value IT is equal to 35 over 3 exponent power of negative 4 over 5 sine 3 over 5t. For value VFT is 35 minus 35 exponent the power of negative 4 over 5t cos 3 over 5t minus 280 over 3 exponent the power of negative 4 over 5t sine 3 over 5t volt. While for question B, we got IT value is 170 over 3 exponent negative 4 over 5t sine 3 over 5t, and for VFT value, the value is 170 minus 170 exponent negative 4 over 5t cos 3 over 5t minus 1660 over 3 exponent negative 4 over 5t sine 3 over 5t. So for conclusion, the result from A and B is not the same because we have different source value for each question.
Warahmatullahi wabarakatuh. My name is Muhammad Luqman Azim bin Muhammad Ayub. My matrix number is AE2010036. Okay, so today I will explain on how to simulate the circuit using the software or in more specific, I am using MATLAB to simulate my circuit. Okay, so for the question, it asks to find or obtain VFT or voltage across the capacitor and IT. And for the question B, we need to obtain V across capacitor and IT, but the ISA is 30 UT. So we go to the MATLAB, and then based on the question, we will need 3 resistor, 1 inductor and 1 capacitor. So using RLC series branch, we can obtain all the components. Okay, first we need to arrange all the components based on the question. And then we choose which component in the RLC series branch that we want to use. So for this one, we use inductor and insert the value of inductor. And then the next is a resistor. Still the same, we need to insert all the value of each component. Okay. Okay, so we'll double check the value from the question, and then we start to rotate or rearrange the component that we already enter the value. Next, we also need a DC voltage source, so we can find through the MATLAB and choose it. Okay, so this is the voltage. Okay, and then we reposition the DC voltage source, and then as the same as the other component, we need to insert the value of the voltage source. Next, we find the control current source. Okay, and arrange it in the circuit. And then we start to connect all the component with the wire. But as you see, at the top right corner of the circuit, I don't connect because I want to put the current measurement over there. We enter the value of ISA, which is for the first question is 3. After that, we connect ammeter into the node or the branch that we want to measure. And then we connect the polarity of the ammeter, and this is quite crucial, and we need to focus not to do any mistake into connecting the polarity. And then we put FFT and ABS, as well as we enter the scope and also the display. These two components is to make sure we can observe the graph of the current and the value of the current easily. Okay, then we connect the component. Okay, and then we insert the voltmeter to measure the value of voltage across the capacitor, and then we need to connect the voltmeter. Again, the crucial part is on how we need to connect it with the correct polarity. As the same as a current measurement or ammeter, we need to install FFT, ABS, scope, and also display for the voltage measurement. Okay, next for the control current source, we need to install or connect the control current source with the pulse generator and ABS. So we only need to search for the component and connect it properly. As all the components are arranged and connected successfully, we need to put power GUI to activate this simulation. And then we can run the simulation. Okay, as the value shows in the display is the value of voltage across capacitor and also the current. And then the scope also can show the graph, and on that particular toolbar, it can show the value of the voltage across capacitor in the particular time. Okay, as well as the current measurement, we can also obtain the graph using the scope, and also can shows the value of current in one specific time. Okay, so that's all from me for the simulation part. Thank you so much.